This is Stellar Stories, and this is the A to Z of science you probably haven't heard of. We'll just dive straight in. A is for axions, tiny ghost-like particles that might be floating through you right now by the billions. Why do physicists love them? Because they could solve a deep puzzle in quantum physics and might be the key to dark matter, the invisible stuff holding galaxies together. Some labs are even trying to listen for axions by picking up faint radio signals they might leave behind in magnetic fields. So next time you feel a chill, maybe blame an axion or two. B is for Bose-Einstein condensates, the fifth state of matter and one of the weirdest things physics has ever cooked up. Take a bunch of atoms, chill them to just above absolute zero, and they stop behaving like separate particles. Instead, they merge into a single quantum state, acting as one big superatom. It's not solid, liquid, gas, or plasma. It's something else, a strange, ghostly state where quantum effects show up on a visible scale. First predicted by Einstein and Bose, this bizarre matter was finally created in the lab in 1995. And when it forms, it's like watching individual musicians suddenly play one perfect synchronized note, as if the particles forgot they were ever separate at all. Cold enough, and the universe forgets how to be normal. Okay. C is for cryptobiosis, nature's ultimate pause button for life. Some tiny creatures, like tardigrades and nematodes, can basically switch off their metabolism when conditions get brutal. Extreme cold, boiling heat, radiation, even the vacuum of space, no problem. They dry themselves out, curl up, and wait, sometimes for decades. When it's safe again, they wake up and get back to business, like nothing happened. Cryptobiosis shows us that life can play dead better than Hollywood zombies ever could. D is for Dyatlov Pass anomaly, one of the creepiest mysteries in modern science. In 1959, 9 experienced hikers died in the Russian Ural Mountains under bizarre circumstances. Their tent was slashed open from the inside. They fled into a snowstorm barefoot, and their bodies showed strange injuries and traces of radiation. Over the years, theories have ranged from secret weapons tests to freak avalanches to infrasound, a low-frequency hum that can mess with your brain and cause sheer terror. To this day, it's a chilling reminder that nature and physics still hold secrets we don't fully understand. E is for epigenetics, proof that your DNA isn't the whole story. Turns out your environment and life choices can switch your genes on or off like a cosmic light dimmer. Stress, diet, and even your grandmother's traumas can leave chemical marks on your DNA, and these tweaks can sometimes get passed to your kids. So next time you blame your parents for your weird traits, remember, it might be your great-grandparents you should be yelling at. F is for femtotechnology. If nanotechnology works with atoms, femtotechnology dreams even smaller, manipulating matter at the scale of quarks and subatomic particles. It's so theoretical, it makes nanotech look primitive. Some sci-fi writers imagine it could build materials stronger than anything we know, or even reshape matter itself, atom by atom, quark by quark. In reality, we're nowhere close. But the idea alone proves our curiosity isn't afraid to shrink to the edge of reality itself. G is for gravastars, the cosmic pranksters that might be fooling us into thinking black holes exist. Instead of a singularity hidden behind an event horizon, a gravastar is theorized as a bubble of dark energy with an ultra-thin shell of matter. From far away, it behaves almost exactly like a black hole. It bends light, traps anything that gets too close, and messes with space-time. But inside, no infinite gravity, no point of no return. Just a weird, dense void that might help explain some unsolved riddles about our universe's most extreme objects. H is for holographic principle, a radical idea that everything in our 3D universe might be encoded on a distant 2D surface. It's like saying reality is a cosmic hologram. What you see as depth and volume is information smeared on a faraway cosmic film. This mindbender comes from black hole physics. Equations suggest that all the information about stuff that falls into a black hole can be described by the surface area of its event horizon, not its volume. Stretch that to the whole universe, and you get a theory so weird even physicists can't decide if it's genius or madness. I is for isochron dating, the scientific cheat code for figuring out how old rocks, meteorites and planets really are. Unlike simple radiocarbon dating, isochron dating uses the ratios of different isotopes and plots them on a graph. If the data falls on a neat straight line, bingo, you get an accurate age and you can cross-check for contamination. It's a clever trick that helps geologists and planetary scientists date stuff that's billions of years old, from Earth's oldest minerals to moon rocks brought back by astronauts. So next time someone asks how we know Earth is ancient, tell them about isochrons. J is for joule thief, an adorably sneaky little circuit that steals leftover power from batteries you'd normally toss away. It works by boosting low voltage up just enough to light an LED or run tiny gadgets. Tinkerers and electronics geeks love it because it's simple, cheap, and turns dead batteries into zombie batteries. So if you ever see a DIY flashlight running on what should be a useless 8AA cell, there's probably a joule thief hiding inside, quietly defying wastefulness one electron at a time. K is for Kugelblitz, which sounds like a sci-fi weapon, but is actually a theoretical black hole made entirely of light. Imagine cramming so much pure radiation, say a colossal laser blast, into a single spot that its energy warps space-time so extremely it collapses into a black hole. No matter, no collapsing star, just raw light bending reality into a gravitational prism. No one's made a Kugelblitz yet, thankfully, because good luck containing that, but physicists love pondering it to push the limits of general relativity and our understanding of energy and gravity. L is for Lichtenberg figures, nature's way of turning lightning strikes into art. When a powerful electric discharge passes through an object, like a piece of acrylic, wood, or even human skin, it can leave behind a branching tree-like pattern that looks like a frozen bolt of lightning. These figures are hauntingly beautiful, but in humans, they're also a reminder of just how much raw energy lightning carries. Some artists even create Lichtenberg sculptures by shooting high-voltage electricity through blocks of resin, capturing that wild, fleeting spark forever. M is for muons, the heavier, moodier cousins of electrons. Muons rain down on us constantly as cosmic rays hit Earth's atmosphere, and they're a crucial tool in particle physics. Scientists use them to peer inside volcanoes, ancient pyramids, and even nuclear reactors, because muons can pass through solid rock with ease. They also mess with the standard model. Experiments keep finding weird behavior in muons that hints at physics beyond what we currently understand. So if one day we rewrite the laws of physics, don't be surprised if muons are the troublemakers behind it. N is for negative mass, an idea so strange, it sounds like physics playing an April Fool's joke. What if there was matter that didn't attract things, but repelled them? If you pushed on it, it would accelerate toward you instead of away. In theory, negative mass could be used to make exotic things like stable wormholes or warp drives, the holy grail of sci-fi travel. Some experiments with weird fluids and quantum tricks have hinted at negative mass-like behavior in the lab, but so far it's still firmly in the maybe someday, maybe never category of physics. Still, it's a delicious thought. Anti-gravity, anyone. O is for orphan planets, lonely wanderers adrift in the galaxy with no star to call home. These rogue worlds were probably born in solar systems like ours, but got booted out by gravitational chaos or violent cosmic events. Some may be Earth-sized, others could be gas giants drifting in eternal darkness. Despite their gloom, orphan planets might have internal heat or thick atmospheres keeping them warm enough to host alien life deep underground. So next time you imagine a cold, empty void between stars, remember there might be homeless worlds out there carrying secrets in their frozen oceans. P is for piezonuclear reactions, a controversial claim that under intense pressure, ordinary materials can trigger nuclear-like reactions without high temperatures. Some fringe researchers have reported seeing unexpected energy releases or strange isotopes when crushing certain rocks or using ultrasound on liquids. Mainstream science is skeptical. Many experiments can't be replicated. and some think it's just experimental error. But if piezonuclear reactions turned out to be real, they could change how we think about nuclear energy and geological processes. For now, they live on the edge of science, part mystery, part wishful thinking. Q is for quasi-crystals, materials that defy the neat, repeating patterns we see in ordinary crystals. Discovered in the 1980s and mocked at first, quasi-crystals have an ordered structure but never repeat exactly, like a pattern that's both symmetrical and endlessly non-repeating, kind of like a cosmic kaleidoscope. They can occur naturally, even found in meteorites, and are tough, slippery, and fascinating to study. The discovery won Dan Shechtman a Nobel Prize, proving once again that nature loves to break rules humans thought were unbreakable. R is for Rocco's basilisk, one of the internet's most cursed thought experiments. It goes like this: imagine a super powerful AI in the future that punishes anyone who didn't help it come into existence. Just knowing about this idea means you're now theoretically on its naughty list if you don't dedicate your life to building it. It's a mental trap that blends philosophy, AI ethics, and psychological horror all in one. Most rational people shrug it off as nonsense, but it still freaks out AI nerds to this day. If your brain feels violated, congratulations, you've met Rocco's basilisk. S is for sonoluminescence, bubbles that flash with light when sound waves slam into them. Imagine blasting a tiny bubble in water with intense ultrasound. The bubble shrinks so fast and violently that it emits a burst of light lasting just trillionths of a second. Some scientists call it the star in a jar because the temperatures inside might briefly reach tens of thousands of degrees, hotter than the sun's surface. No one's cracked exactly how it works yet, and some even dream it could one day help with clean fusion energy. For now, it's just nature's way of showing off with a sparkly party trick. T is for tachyons, hypothetical particles that always move faster than light. They're a staple in science fiction, quantum theory debates, and the dreams of physics students pulling all-nighters. If tachyons existed, they'd break Einstein's special relativity by carrying information faster than light, leading to possible time paradoxes. So far, they remain purely theoretical, but the equations that allow them pop up naturally in some U is for unparticles, a truly bizarre idea from particle physics. Unlike ordinary particles, unparticles wouldn't have a definite mass. Instead, they'd behave more like a cloud of stuff that can't be pinned down. The concept was cooked up by physicist Howard Georgi in the 2000s as a way to explain strange missing energy signals in experiments. If unparticles exist, they'd shake up our standard model and might even connect to dark matter mysteries. For now, they're theoretical phantoms, not quite particle, not quite wave, just wonderfully weird. V is for vacuum fluctuations, the ultimate cosmic fidgeting. In quantum physics, even empty space is never truly empty. Instead, it's buzzing with tiny bursts of energy popping in and out of existence for the briefest moments imaginable. These random fluctuations mean that pairs of virtual particles appear, borrow energy from nothing, then vanish again. And this ghostly dance affects real stuff, like the Casimir effect, where two metal plates in a vacuum mysteriously attract each other. Some scientists think vacuum fluctuations might even be connected to dark energy, the force accelerating our universe's expansion. So, the next time you feel unproductive, remember, even nothingness can't sit still. W is for Wigner's friend, a mind-bending twist on Schrödinger's cat that messes with your head even more. It asks, what happens if an observer inside a lab sees a quantum outcome, but an outside observer treats the whole lab and the first observer's brain as still being in a quantum superposition? It exposes a deep tension in quantum mechanics. When exactly does reality collapse into one outcome? Wigner's friend shows that our understanding of measurement, observation, and consciousness is still on wobbly ground. In short, physics gets philosophical very fast when you start spying on your mate in a quantum box. X is for xenobiology, the speculative science of life as we don't know it. It asks, what if alien life doesn't just look different, but uses totally unfamiliar biochemistry? Silicon instead of carbon, ammonia oceans instead of water, or energy sources beyond sunlight. Xenobiologists study extreme life on Earth to guess what weird forms might exist on other planets, or even build synthetic life in labs that breaks our usual rules. It's the ultimate what if for astrobiologists and science fiction fans alike. Proof that nature's imagination probably outpaces ours by light years. Y is for Elim, an old word for the primeval cosmic soup right after the Big Bang. Before galaxies, stars, and atoms formed, the universe was a hot, dense plasma of particles and energy. Pure chaos, slowly cooling and expanding until matter as we know it began to take shape. Ancient scholars used Elim to mean the raw, primordial substance of everything. Today, cosmologists revive the term when talking about that first fiery instant when time, space, and the building blocks of reality all blinked into existence. So, next time you look at the night sky, remember, it all started with Elim. Z is for 0-point energy, the lowest energy a quantum system can have, even at absolute zero. In other words, even if you cooled something to negative 273.15 degrees Celsius, its particles would still jiggle with a ghostly energy that can't be removed. This weird leftover power is a byproduct of the uncertainty principle. Sci-fi loves to imagine tapping into 0-point energy as an infinite power source, but in reality, harnessing it is, well, still fiction. Yet its existence is real, proven in subtle ways like the Casimir effect. It's the quantum whisper that the universe never truly rests. Thanks for your watching the A to Z of weird science. And remember, this is still a tiny channel, and every interaction from you helps more than you know. I respond to all comments, so tell me, which was your favorite? See you next time.